All right, Kino. I'll do all these solutions for you, right? And if there's any questions at all, man, but in regards to anything that I'm doing here, don't hesitate to ask me. I'm only happy to help you out, all right? I'm finished teaching my lads there since last Friday, so I'm at nothing now really except doing a few bits and pieces around the place. So just make sure to ask me whenever you have a problem, okay? So good man, you've done question one and two, which tells me that you've no problem, okay, working out the volume and the surface area of a sphere, which is excellent. So I don't need to go back over the formulas. Okay, but we will be using them obviously for all of questions that we're doing here. And we can see down in question 8 that we also have a cone on top of a hemisphere, but we'll talk about that when we get to it. So question 3 says collect or calculate, correct to one decimal place, the radius of a sphere. Okay, so we're looking for the radius of a sphere. And it says with a surface area of 200 centimeters. Okay, so this is question 3. Okay, part A. So they're telling us that the surface area, okay, of a sphere is equivalent to 200 centimeters squared. All right. Now, we know over here on the right hand side, SA, short for surface area, okay, is equal to 4 pi r squared. So we know the surface area is equal to 4 pi r squared. So instead of surface area over here, I'm going to replace it with 4 pi r squared. Now that's equal to 200 centimeters squared. So my surface area is equal to 200 centimeters squared. So instead of surface area, I'm going to replace it with the actual formula itself. And they want me to find the radius, okay? There, I need now to isolate or. I need to get or on its own key, okay? So I'm sure you've done this before with algebra, rearranging formula. So what I need to do here is I need to get rid of anything that's attached to or. So the first thing that's attached to there is 4 pi. So if I divide both sides by 4 pi, so what you do to one side of the equation, you must also do the other. So that's going to get rid of this 4 pi, and that's gone. So now on the left-hand side of the equation, f of r squared is equal to, okay, and if you divide 200 by 4 pi, okay, you get 15.92. Okay, now we want or, not or squared. So how do you get rid of a square? You square root it. And what you do to one side, you must do to the other. So that square root will cancel out that square. So you're now left with or. And or is equal to the square root of 15.92, which is 3.99 centimeters. Now, I know they want you to round it off to one place. So you could say here or is equal to 4 centimeters. All right. And that's B. Or sorry, that's A, excuse me. All right. Now, let's move down here to B. So what are they telling us here now? They're telling us that has a volume, this time a volume, okay, of 200 centimeters. So they want us to find the radius of a sphere that has a volume equivalent to 200 centimeters cubed. Well, what's the formula for a volume or of a sphere? The volume of a sphere is 4 over 3, okay, pi r cubed is equal to 200 centimeters cubed. So watch, instead of saying, okay, the volume is equal to 200, what I'd say, well, what was the formula for the volume? It's this. And what are we looking for? We're looking for or. So once again, we're going to try and isolate or. So all I do, Keen, is again divide both sides, in this case here by 4 over 3 pi. That 4 over 3 will cancel out with that, and the pi will cancel out with the pi, leaving us with or cubed. Okay, also divide this side by 4 over 3 pi. Okay, and when you do that, you get 47.75. I just rounded off to two decimal places. Now you've got a cube here on the or. How do you get rid of it? Well, you cube root it. What's a cube root? It's just a square root with the cube on the outside. And you've got a function on your calculator that will do that for you. Okay? And what you do to one side, you must do to the other. So that cubic root will get rid of that cube there. Okay? So now you're left with or. Obviously, you punch that into your calculator, Keen, and it will give you back, rounded off to one decimal place, 3.6. And don't forget unit, in this case here, centimeters. All right? Now, that's question 3, don't forget. And as I said, Keen, if there's any questions, just ask me. All right, we'll go down to a new page here for you. Okay, moving on to question 4. Okay, it says the volume of a sphere is 50 meters cubed. Okay, find its diameter. All right, again, we're dealing here with the volume of a sphere. So they're telling us that the volume, okay, is equal to 50 meters cubed. Okay, instead of the volume key, what am I going to write? I'm going to use a formula, which is 4/3, okay, pi r cubed is equal to 50 meters cubed. Now they want me to find the diameter. Well, what is related to the diameter in this question here? Okay, it is of course the radius, because twice the radius will give you your diameter. So if we isolate r again, work out what r is, and double it, we'll have the diameter. So let's try and isolate r. Okay, so first thing I'm going to do is divide both sides by 4/3 pi. What you do to one side of the equation, to keep it equal, you must do to the other. So that 4/3 pi cancels out there, so you're left with r cubed. And then you go into your calculator, all right, and then you type in 50 divided by your 4/3 pi, and you get 11.94. Okay, again, I'm rounding that off to 2,000 places. Again, now you get your cubic root, both sides, because you don't want r cubed, you just want r on its own. That'll cancel out that. So you have r. Okay, you work that out there, and you get 2.23, okay, meters. Now, that's the radius, so the diameter is twice the radius, so 2 times 2.33 will give us 4.46 meters. Okay, and there's question 4, Kino. All right, man. Okay, now, question 5. So question 5 says, what is the volume of a sphere that has a surface area of 400 centimeters cubed? Okay, so they're asking what is the volume? Well, the volume of a sphere, okay, is 4/3 pi r cubed. Okay, what do we need to make that formula work? Well, we know 4/3 is 4/3. We know what pi is. It's 3.14, so on and so forth. So what we need is we need r. Once again, we need to find out what the radius is. And what information have they given us? Well, they've told us that the surface area of this sphere, okay, is 400 centimeters squared. Okay. Instead of surface area, what can we write? Well, we can write what the surface area of a sphere is. And the surface area of a sphere is 4 pi r squared. Okay. Now what can we do? We can now go and find out what r is. Divide both sides by 4 pi. We'll get rid of that first. What you do to one side, must do to the other. So r squared, okay, will be equal to 400 divided by 4 pi is 31.83. Again, rounded off to 2 decimal places. Square root both sides in order to get rid of that square. You get r is equal to 5.64 centimeters. Now, let's go back up here. Now we can work out what the volume is because we now have what r is. So let's bring that over here. Okay, we can say, well, the volume is 4/3 pi. We know r is 5.64 to be cubed. Into your calculator, punch that out, okay, and it will give you back to 1 decimal place 751.5 centimeters cubed, because you're talking in volume. All right, so that's question 5 for you, Keen. Okay, question 6. Again, Keen, if I go too fast here now or anything like that, obviously you can use pause this and work back over it. But if there's any questions, please get on to me, dude, and ask me, all right? Okay, question 6. To get a little bit trickier down here now with all the English, and you have to understand what's going on. So I'll try and slow this down a little bit. So a cube of metal of side 5 centimeters has a hemispherical hole of a diameter of 4 centimeters cut into it. So if you can imagine, all right, now my drawing isn't the best, Keen. Okay, so here, I should give myself more space. So obviously a cube, you know what a cube is. Okay, looks something like that. Okay, and they've told us that the sides here, so the width or the front width is 5 centimeters, the depth is 5 centimeters, and the height is 5 centimeters. And then they're saying here, I'll use a different color, use green, that there's like a hemisphere kind of cut into it. So if you can imagine, it's like what would you, do you know the chalk for a snooker cue? Do you know the way that you put the chalk on top of the cue and you kind of rub on the chalk to it, and slowly but surely in the chalk, you're going to have this perfect hemisphere kind of taken out of it. Okay, so that's what they're talking about here. All right, so this hemisphere is going to be taken out of that cube, and what they want to do is find the volume of the resulting shape. Now, what do you do? Well, the first thing you look at is if you had a perfect cube, okay, what would be the volume of that cube without that hemisphere being taken out? Well, the volume of a cube is simply the length by the breadth, sorry, by the breadth by the width. So the volume is going to be simply 5 by 5 by 5. So the volume of that is 125 centimeters cubed. Okay, now what we do is we're going to get the volume of this hemisphere. Well, the volume of a sphere, okay, is 4/3 pi r cubed. Okay, now we don't want the full sphere, okay, we want a hemisphere, so we want half of it. So we at the end we'll divide by 2 king. All right, just to get half of it. But we'll continue on with the top for the start. So it's going to be 4/3 pi. Now in the question, they tell us that the diameter is 4 centimeters. We want the radius, so it's half the diameter, which is 2 to be cubed. And we're going to half this at the end. So the volume, okay, when you work that out, so 4/3 pi, 2 to be cubed is 33. Again, rounding this off to 2 decimal places, 5/1. And then we're going to divide that by 2 to get the hemisphere, which works out to be 16.76 centimeters cubed. So what do I have? I've got the volume of the cube, and I've got the volume of the hemisphere. So we're going to take the volume of the hemisphere out of the cube. All right, so we're going to subtract them. So down here, I'll do it in a different color pen. I'll do it in yellow. So 125 centimeters cubed minus the 16.76 centimeters cubed will give me the volume of the resulting shape that's left over. Okay, when you do that math, it works out to be 108.24 centimeters cubed. Okay, is a volume of that shape that's left over. All right, Keane. Alrighty, let's keep moving. Okay, question 7. All right, question 7 actually isn't too difficult. What's difficult about it, what gets students a lot of the time, is converting millimeters and centimeters and meters. Okay, the best way to do that is obviously just Google it and look at the conversions and learn the math. All right, now you can do this 2 ways. You can convert the cubic meter to millimeters, or you can convert the millimeters to meters. Okay, you always have to work in the same units. If you don't work in the same units, your answers are going to be way off. So you have to work in the same units. So in this question here, Keen, right? It says, what question are we on here? 7, isn't it? Yeah. A roller skate manufacturing company needs to make 4 millimeter diameter steel ball bearings. Okay, so they're quite small. Okay. And they're asking then how many ball bearings can the company make from 1 cubic meter of steel, which is quite large. Okay. So if you ask me, okay, I would change, because it's easier, I think, the 4 millimeters to meters. Okay, now that works out to be 0.004 meters. Okay, now they are just a matter of learning them off, King, going looking through them. Millimeters to centimeters, centimeters to meters, so on and so forth. Now, I'm going to work in meters, all right? So the first thing I need to do now is to work out what the volume of one of those 4 millimeter diameter spheres would be. All right. Now again, we go back to our formula for volume of a sphere, which is 4/3 pi r cubed. Okay. Now what we do then is we work out 4/3 pi. Now the radius, now the 4 millimeters represents the diameter, okay? And we want the radius, so it's going to be 0.002, okay? 2 cubed. Now where's my calculator? Mulch this out here for you. So we've got 3 pi 0.002 cubed. Okay. Alright, that works out to be a fairly small number. Okay, it works out to be 0.123 Okay, so that's the volume there of one of those hemispheres. Oh, hold up. No, not a hemisphere, sorry, a full sphere, obviously, because we're dealing in ball bearings. All right, so that's the volume of that there. Now, simply all you got to do, man, is if it's 1 meter cubed, we'll divide that by 0.00000000123456733 meters cubed. Okay, and what the hell does that work out to be? Bear with me now, dude. 1 divided by 0.123123433. Okay, that's a lot of ball bearings. Okay, I'm getting 33,030.3. Now, what do you do with that 0.3? Well, in this case here, all right, think about it. How many full ball bearings can you make? You can only make 30,303,030 ball bearings. Okay, that's how many ball bearings you can make. Okay, I hope you understood that. All right, and question 8. All right, last question. Okay, so we're saying a spinning top. All right, consists of a cone of a base radius of 6 centimeters and a slant height of 10 centimeters, and a hemisphere of radius 6 centimeters is shown below. Okay, we're going to give our answers in terms of pi here, so they want to calculate the volume of the spinning top. Okay, if you look at this shape, Keen, we can obviously see it's made up of, okay, again, excuse the drawing, dude. Okay, a cone plus, okay, a hemisphere. Now they want the volume. What's the volume of a cone? Okay, now the volume of a cone is 1/3 pi r squared h. Okay, what's the volume of a hemisphere? That's 4/3 pi r cubed divided by 2. All right, so let's work that out. Change to black pen here. So 1/3, we're going to leave pi as pi, the one in terms of pi. Okay, we know or in this case here. All right, what did they give us? They gave us that to be or, okay, which is 6 centimeters, and they give us the diagonal to be 10 centimeters. Okay, so that pi times or, so it's 6 to be squared times h. Now that 10 centimeters came. If I just bring it over here for a second, all right, over to the side. So I'm going to make a side note here for you. If you look at a cone, okay, that there is obviously or is a radius. The slanted height here, okay, this line is L, and this here, that is H. Okay, now they've only given us L and or in the question, so we need to find H. But what is that? It's a little right angle, okay, triangle. So come down here. I will draw this right angle triangle, and they have given us the bottom, which is 6, it's the radius, and they've given us L to be 10, and we need to find H. Okay, Pythagoras' theorem. So the hypotenuse to be squared is equal to the other two sides to be squared. So 6 squared plus h to be squared. So 10 to be squared is 100. 6 to be squared is 36. and hp squared is hp squared. Bring 36 over here, it becomes a minus. So 100 minus 36 is 64, equal to h squared. I want h, so the square root both sides. So you get 8 is equal to h. So now we can plug in 8 here, okay, for h. Plus 4 thirds pi 6 to be cubed. Okay, it's all in pi, so all we got to do is multiply that out there. So this side here will give us 96 pi, plus this side here will give us 144 pi. Add the two of them together, Keen, and you get the total volume is 240 pi, don't forget the units, centimeters cubed. Alright, so that was the first part of 8. That was 8a. Again, I hope I'm explaining this to you, Keen, and you're understanding it, alright? So 8b then, I want the surface area of the spinning top. Now here's where you gotta be careful, man. Okay. I'll draw this out again. So that's a terrible drawing. Hold on. So if you take the cone, Keen, okay, and then you've got a hemisphere. Okay, so add these again now for your surface area. When you go into your log tables, I don't know if you call them log tables over there, but basically your book that gives you all your formula, all right? And if you look at the cone and it gives you the surface area, it says A surface area just gives you the curved surface area alone, all right? Just the curved surface area. So it doesn't give you the bottom, okay? So the curved surface area is just, see this circular bottom, okay? It doesn't include that circular bottom, all right? So it only gives the curved surface area, which is basically the kind of upper part of the cone. If you can imagine a party hat, you know the way the party hat doesn't have a bottom of it, okay? The outside of that is your curved surface area. So the curved surface area for a cone, all right, is pi r L, okay? So I'm going to write C for curved, S surface area, okay, is equal to pi r L, okay? Now, you've also got then your hemisphere, right? Now, again with the sphere, when you're getting the surface area, it's the total outside of the curved surface area, right? So all you need then is half of that, okay? So the surface area for a sphere, okay, what was the formula for that again? Is 4 pi r squared. And you want half of that, okay? That's all you want, is just half of it. So if you think about it then, this shape here, which is the cone part of it, the curved surface area, plus the surface area of that is all that's going to be exposed. So that's all your surface area. So if you add these two formulas together, that's your surface area taken care of. And again, they want it in terms of pi. So it's pi times r, which is 6 centimeters, L they gave us, which is 10 centimeters, plus 4 pi r was 6 and over 2, because you're halving it because it isn't a full sphere. And 6 times 10 is 60, so that's 60 pi. Okay, plus 60 squared is 36. 4 times 36 is 72. Okay, no, it's not. Hold on. That might be half it. Hold on. 6 2 squared is 36 times 4 is, 144 divided by 2 is 72. So that works out to be 72 pi. You add them two together. Okay. So 60 plus your 72, gives you 132 pi centimeters squared. Okay. Now, I know I did that quite quickly, Keen, right? But at least you have the luxury here with this video that you can obviously stop and pause it and rewind it and fast forward it. But take your time and work through it. And again, man, seriously, if there's any questions, I know it's a little bit difficult when it's just one way and you can't stop me and ask me any questions and I can't confirm with you if you understand what I'm saying. All right, but hopefully this gives you a hand and helps you out. And please, Keen, any questions, man, keep them coming. Don't mind at all, dude. All right. Hope you're all keeping well over there. Tell Aaron and your mum and dad is asking for them. Okay.